Hi everyone, this is Giovanni, also known as CryptoJoe11, and today, for the first time, I will be recording my solutions to the Plutus Pioneer Program homeworks. And yes, I applied and managed to get in the first wave of pioneers that are going to be learning about Plutus and Haskell and how to write smart contracts in Plutus for the Cardano blockchain. So I have pretty much no more than 10 hours of studying and working with Haskell, so I am completely new to this language. I do have though a few years of experience in Scala, about 6, and more than 10 in total on Java. So I have I have quite a few years of experience in programming, but nothing in pure functional programming like Haskell is. A little bit of functional programming in Scala, but not the strong concept like in pure functional programming. So I'm just thinking for fun to record those videos so that even in the future I forget about something, I can just like go back to my own videos and remember how I did something and what was the thinking about the solutions of these exercises. I also want to say that I'm stakeable operator. If you enjoy these videos and you want to support me in my journey into learning Haskell and smart contracts, if you want, you can delegate to my stake pool. The ticker is Easy1. My stake pool is called Easy Staking, and you can find it on easystaking.org. Without further ado, let's get started and let's try to solve this Haskell exercise for smart contracts on Plutus. So this is the project, Plutus Pioneer Program. We're already at week 2. Week 1 is relatively simple to do. There is lots of installing and setting up the environment. This time around with week 1, it was mostly setting up the environment. With week 2, we are actually starting to get into the nitty-gritty details. The first thing that Lars Bruns, I think it's his name, this guy here, is basically teaching us how to validate as soon as we try to interact with the blockchain and with the smart contracts. So the first step is to validate that whatever we are doing is actually possible, and if we want to interact with smart contracts, if everything is fine. So the second lecture, there is a video on YouTube, is 75 minutes long, but what the exercises are going to be about are basically fixing and completing this is, what is it, week 1, week 2, fix and complete those two homeworks. For simplicity, I've already checked out this thing. I'm going to be using IntelliJ IDEA, and here is the source code. So this is homework number 1. Up here you can see into the name of the file, Haskell. I will follow Lars' suggestions, and at the moment, because I still have very few hours of experience in Haskell, I will not go too much deep into some concept, like for instance all the things about distance here, and I will basically just copy and paste as he recommended the definition here. But let's start from the top. The first thing that we have to do is to implement this validator. We know that the 3 types that are passed here are the datum, the redeemer, and the context. So what we have to implement here is the redeemer, and based on the parameters passed into the redeemer, in this case are 2 booleans, we will have to implement the validation condition. In fact, as you can see here, there is a fix me. So what we can do here is relatively simple. I use my Scala knowledge here to basically fix this thing up, and it's basically just called this flag 1 and flag 2. Basically what's happening here is that Haskell is able to decompose and associate those 2 types into those variables, or values I should rather say, and then we can now use those 2 names, values with names in here. And because what we want is that whenever those 2 booleans are equal, all that we have to do is to say that flag 1 is equals to flag 2. So whenever this condition is true, the validator passes. Also, what we want to do is that we pass an error is if we want to log an error if these conditions are false, and the way we can do this should be trace if false, and then we pass the string unleasher that is error flag are different, and then we shouldn't pass anything else. I think there is a typo here. This should be trace with the C. Now, if we want to test this thing, what we have to do is to run cabal rebel into the folder week02, and exactly in that folder, nowhere else, because otherwise we'll not find the cabal file and we'll give an error. So far looks good, because if I go like colon L source src week02, and then this is homework 1.hace. The module is loaded correctly. It means that this file so far compiled as well. So just to recap here, we have kind of pattern matched against those two types here, and we just gave them a name. Then we're retracing an error if the result of this one is false, and the error that we are printing is this one. Let's put an exclamation mark just to make it more dramatic. I'm gonna be copying the steps from the definition of the types from the typed example. At the moment, as Lars said, we are not interested in fully understand what's going on here, because it's still copy and paste. I still haven't learned about instances and data types. I will definitely do this in the future. Type instance will do this in the future, but at the moment I'm just happy to stick with copy and paste, because these are like way more advanced concept for me that I can't grasp yet. At the moment I just want to stick with the solutions. The examples that Lars used here is just with a simple integer, but we can't use simple integer anymore. At the moment we have two booleans. So what we have to do, we have to change the type here, and then say bool and bool. So first of all, what I want to say is that whenever we use parentheses like this one, I learned this one from the Learn Your Haskell book that I definitely recommend, at least the first few chapters, because are quite simple to follow, especially if you have already a little bit of programming experience. There are the tuples. Tuples are basically two things put together, and in Haskell, as in Scala, you can do this just defining them with the normal brackets. So you can have tuples of integers like this one, or you can have tuples of whichever type. Like in this case, is a list of characters in Haskell, or string, and then an integer. So as you can see, this is a tuple and this is a tuple. I definitely recommend you to take a read of this paragraph, because it's going to definitely help you understanding what's going on into the code. The second thing that we have to do is implement this inst. Even in this case, I will just copy and paste whatever was done previously and simply update what was wrong. Even in this case, if you remember, it was using integer into the previous example, and even in this case, we have to update the type, and I'm passing a bool. And this, also in this case, let's see if the compilation is still okay, and if is everything okay. So one module loaded, so we're still good to go. And then the next three things are very, very basic, very, very simple. Even in this case, we'll copy them from here. We'll just copy the full block. There is not really magic happening here. Basically, what we're passing is the implementation of inst, and then those scripts are basically generating it's the boilerplate to generate the instance, the validator, and the validator hash. And this one is going to be, as Lars taught us, the script actual address on the blockchain for this script. And there shouldn't be anything else to be implemented, because this was all fixed by Lars. So let's give it a compilation again. I think if I can just go semicolon R for reload, everything looks good. So we can now launch our playground. I need an X shell, actually two Nix shells. We go back to the documentation and we go get the commands we need to start the environment. That is not here. Ah, there we go. We have to change into this folder. when the Nix shells are ready, and then we should be good to go. Bear with me a couple of minutes while Nix shell is actually starting. And then we'll test this one inside the simulator, the playground. Few more seconds and we should be good to go. Like, you can, if you could be here, you'll be hearing the fan of my laptop just going crazy. But there we go. We are in here. Let's change the folder into the bot of this, and then we need the playground server, and then start npm run start in this other folder. So when those two bad boys are ready, we should have localhost at port 8009 up and running. So just a few more seconds before this is all started. So the backend is ready. We need the front end up and running. And I think that should be almost it. A few more seconds, bear with me. So the first of the two exercises, I found it quite straightforward because it's just a basic, how to say, is a basic just tweak of the whatever we had already seen previously in the lectures. While the next homework is going to be a little bit more complicated because there is a little bit of learning and investigation needs to be done. So here we go. We are into the code. So this is homework 1. I'm just going to be copying everything, replace. As Lars said, we have to remember to nuke and delete this line of the module because the playground is going to implement this thing by itself. So all that we have to go is to press compile and wait for it to be completed. Compilation is successful. So there we go. Let's go into the simulation. So what we do, the exercise here was to basically make a donation. All the wallet can donate, and then one wallet is going to collect. So we create a third wallet here. Let's say that this wallet is very poor at the beginning as 0. So the first wallet is going to donate, and it's going to donate 2. Then we have to wait for 1 block. Then we say that wallet 2 makes a donation of 3. Then we add another wait. We say we wait for 1 again, and then we say that wallet 3 grabs everything. And then the 2 conditions need to be the same in order for this thing to happen. But now what I'm going to do is to add another wait. And it was funny because I wasn't putting this one earlier on. And then it looked like something wasn't working. So always remember to put this one here, because whenever we do the transaction, we need the transaction to be recorded on the ledger. So we do need to wait 1 block so that that transaction gets persisted. This is a little bit of a gotcha. I'll show you an example in just 1 minute. So let's make an evaluation. Everything is correct because the 2 booleans are exactly the same. So if we do like this, we should see 4 transactions, I think. 1, 2, 3 transactions in total. So let's wait for this thing to do its magic. So this is the Genesis slot, Genesis transaction. We see the 3 outputs here. The 3 wallets are created. There are 10, 0, and 3, 10, 0, and 10 again. The wallet 3 has 0 ADA. So the first one is the script gets created with 2 Lovelace. This is the first donation. The second donation is of the other one. It donates 3. And then the third transaction is basically the third wallet that is basically collecting all the donations. And here is nice to see that there are two despite the script being 1, there are actually 2 addresses for the same script with fund inside them. Whenever I was working on this one and studying about this earlier on, I thought that I would have seen the amount to be increased. So from after the first donation of 2 and the donation of 3, I would have seen like the donation going to 5. But this doesn't work really well with the extended UTXO model of Cardano. And what happens basically is that every donation goes in its own address within the space of addresses of the script. So that means that whenever the third script is collecting all the donations, it will have to go through all the UTXOs and collect all the Lovelaces. Otherwise, this will get stuck on the blockchain and they won't be accessible anymore. And if we go to the bottom, we will see that while initially the wallet 3 started from 0, now donation 3 plus 2 is 5, and then the wallet 1 donated 2 and went down to 8 from 10, and then the wallet 2 went down to 7 from 10 as well, because it donated 3. Everything is good. So let's close this one, and then because I was mentioning this one earlier on, let's remove the last weight and evaluate everything from scratch again. As you will see quickly and shortly, there are only the 2 donations, but there is no collection. This is not a bug. Simply, the transaction wasn't persisted on the blockchain, because you need the transaction to be persistent. So if I put the weight back in, so basically this is waiting for the transaction to be persisted on the blockchain, and so basically the grab is actually happening. It's recorded and processed. So there is the grab. Perfect. So now let's try to check if the way I implemented the check is correct. So we have a true and a false. Those 2 flags are different. So we will see as well as before only the donations, but the collection there will not be, because there is actually an error. So if we go and check the logs, we will see that the script failed, and somewhere here I actually can't remember the error that I put into the code. I'll just be looking for error. And we say that the full sentence is script failure. Just 1 second, I'll be back in a second. Right, and I'm back. Sorry, I made a very small error. So I forgot to add the dollar sign here, and I'll show you in a minute what this thing is. It's something completely new to me that I learned just a couple of hours ago. But this is what I was actually missing. So I'll do the compile again, and then I'll run the simulation again, simulate, and then evaluate. As you can see, the 2 things are still different. The 2 flags are still different. We're still waiting for a block. We run the simulation, and still 2 transactions, but now if we look for error, we actually see that the error is still here as it was earlier on, but we can also see the message that we printed earlier on. This error flag are different. So this is exactly what is going on here. Sorry, I lost it. There we go. This is the error that we shown earlier on, and this is because the 2 flags are different. So this is basically the end of the first exercise, and if we go back to the documentation, I very quickly read and googled for the dollar sign, and it's basically a type class as well. This basically is required in order to tweak the association of function calls on a line. Again, I apologize if I'm not using the right wording, but it's only 10 hours that I've been working with the Haskell, so things could be a little bit not clear in my head. Basically, what we are saying here is that trace if false is basically getting 2 params, and it's getting this one, and then it's getting this one. And basically we need this condition, to be evaluated first and then consumed in 1 parameter, and then is passed alongside this one inside trace if false. If we forget to do this one, I think that the flag 1 is going to be passed as first. So this one is going to be passed as a first param, this one is going to be passed as a second param, and then this one is going to be used as a comparison after. So if we want things to be evaluated properly, we want these 2 bad boys to be evaluated first, and so this one, that's exactly what it's doing, because this is like changing the level of priority, and this is documented in that document that I was showing you earlier on. And then this is then correctly passed into the trace if false, and then if this one is false, this error line is printed. I will link the details of that of the dollar type class into the description of the video. Let's get then now down to the second, and this basically finishes the first homework. I could be messing around a little bit more with the playground, but I've done this one earlier on already, and everything is working, so I'm just happy to go to the second exercise. Second exercise that is very similar as well, it adds a very nice level of complexity. Yeah, this is gonna look really a lot like the examples of real smart contracts. So yeah, let's see what happens. So far, the redeemer that we've seen so far, it was either a primitive type like an integer, or a combination of primitive types. In this case, were put together tuples. But we want to just make it just a little bit more difficult. So we want to introduce data types so that we can pass an arbitrary combination of attributes. And this can be like, they can be other wallet addresses, they can be like whatever we want. So we're going to be seeing this one possibly a lot. But this is like already giving us like the fundamental tools to build more and more complicated smart contracts. So this is the very first step to complicate things, and it's fantastic that we're already doing this. Lars is doing a great job. So yeah, let's start to do this now. So what we have to do now, the first thing again, is to implement the fixme, the validator. We had previously like bool and bool, so we just needed to decompose this thing into two, and now things are a little bit different. As a Scala, I'm using my Scala background to cheat a little bit and try to get down to the things quickly. If this was Scala, I would have written something like flag 1 and flag 2. In fact, I got stuck to this line because the syntax wouldn't match like for hours, and I was just like, what am I doing wrong? So what I'm doing wrong here are two things. First of all, there is no comma required, and second thing, the order of the parentheses is ever so slightly different. So this is really how this thing should read. Also, because whenever we define a data type like this one, Haskell automatically generates two functions called flag1 and flag2. So basically that if we wanted to access the flag1 attribute or flag2 attribute of an object of type myRedeemer, what we should really do is flag1 and then object name of j1, for instance. So the function flag1 exists already in this space, in this namespace. I have to rename this one maybe f1 and f2 so that there is no collision. Actually, I'll tell you something. Let's do this and I'll show you exactly what is going to happen. If I do now load source week 2 homework to Haskell, we're gonna get you see here is defined but not used. Okay, no, this is an error, and then there is shadows. You see flag2 shadows an existing binding. I think the same happens for f1 as well. So this is exactly what I was telling you. In this namespace there is already a function called flag1 that basically extracts this value from objects of type myRedeemer. So if we want to avoid clashes and warnings, what we have to do is to introduce new names. So if we do this one, we can finally implement the equality function, and we do like this. So if we go -r again, there shouldn't be any error. In fact, there is no more warning about shadowing and all this kind of jazz. Right, we've done already the hardest part of the work, because this is the first time that we're working with the validators and with the data types. Everything else has already been done for us, so let's try to fix whatever is left. So let's start from the easy part first. So source address, validator, valash, this is all stuff that is going to be exactly the same. So we copy and paste. Maybe in another day I'm going to be exploring what those functions really do. At the moment I don't care, so I'm happy to just do copy and paste. So now we have to fix the inst. So the inst in this case, we're going to be copying again what was here. We just put it here. But now we don't have the mySillyRedeemer anymore. We just have the myRedeemer. So I just have to replace the name. We're going to be still creating using the what's it called? Haskell templating and to generate the bytecode for this one and for the wrap as well. The only thing is that we have to put the right type name here. I think Lars has already created the unstable make is data for the redeemer, so that the type classes for the myRedeemer are already been created for us, and there is nothing else to do. The last thing that we have to do is to generate the type. Even in this case, I'm going to go to the tape data and I'm going to be copying and paste this one here. Again, I can't use the mySillyRedeemer because this was for the other example, but I just have to do this one instead, and I think we are good to go. We're going to be doing a reload, and everything should still look good. So I'm going to be copying the code, go back to the the playground. I'm going to be deleting this one. I'm going to be running the compilation, and because the bindings are exactly the same, my previous simulation should still be there, so I don't have to recreate everything from scratch. The endpoints are still the same. No, it's been removed, so I'm going to add the third one. Wallet 3 is going to start from 0. Wallet 1 is going to be donating 2. Then I wait for 1 block. Actually, this time I will not wait for no block. No, I'll wait for 1 block. Then we give from here. We'll give 5 this time because this guy is very generous. We'll wait for another block here, and then we do that. Wallet 3 grabs everything, and then we add another wait. So we go for an evaluation. The 2 flags are still the same. If everything goes fine, we should see 3 transactions materializing. Generation, give 1, give 2, and collect all the coins. And if we go to the bottom, we see that our wallet 3 has 7. We're gonna screw the things up and then reevaluate, and we will see that the grab will not work because the validation fails. Accordingly, there we go, donate 1, donate 2, and wallet 3 is still empty, and the message is exactly what we were expecting. Sorry, I forgot to implement the failure. So this is trace if false error. $sign this time around. I will not forget about it. We go back into the editor, stick this one here, compile, and hopefully the simulation is still here. Yay, happy days, evaluates. We should see nothing happened. We should see an error, and the error is error. There we go, fantastic. I haven't done one test so far yet. That is the following. What happens if I remove the weight between the 2 give? I guess that there should be just 2 transactions. Actually, there should be just 1 transaction in this case. We will see only 1 in which both exactly, yeah, they look together exactly. So there are 2 transactions within the same slot. So both wallets are donating at the same time to the same wallet, script wallet, 2 things at the same time. So the first one is donating 5, the second one is donating 2. So let's fix the receiving, and we will see now 2 transactions, the 2 donation in just one slot, and the collection in the second slot. There we go, yeah, and everything is still working, fantastic. This is exactly what I was expecting. This is absolutely fantastic. I'm really happy. Lars has done an amazing job, and the community is fantastic. I had a couple of issues today. I just logged onto the Discord, and the guys were very nice. So thank you very much. This is dragging already for too long. This is about 27 minutes. I hope you enjoyed this. Joe, if you're looking at yourself, well done for coming back to watch this one again. I want to thank everyone if you made it so far. My name is Giovanni, also known as CryptoJoe101. I have a stake pool called Easy One. If you like the content, you want to support me, you want to support a pioneer of Plutus, please delegate to my stake pool. It's really, really important to me. Yeah, thank you very much, and see you in the next episode. Hoping that in a few weeks' time I'm going to master more and more Haskell, and I am going to be one of the first few people deploying smart contracts on the Cardano blockchain. Thank you everyone. I'll see you around. Bye.